Hi and welcome to Phys 9120, Mechanics for Teachers. You probably remember me from Phys 9110. I'm Liz Anksman. I'm the Program Coordinator for the Graduate Certificate in Physics for Science Teachers and the First Year Physics Director at UNSW. I'd like to introduce Dr. Yael Allgarten to you. Yael's put together all the lecture materials and problems for this course, so I'll hand over to her now to explain to you a bit about her background and how she's gone about setting up this course.
Thank you. So, as I said, I have a degree in physics from this university and a doctorate from engineering, also from this university. And I've put this course together with three things in mind. So I think there's three important things to keep in mind when teaching physics. And the first is to provide the context of what you're teaching, so historical context, but also daily context and like the justification. So the historical context, there are thousands of really interesting people who made some phenomenal discoveries, and I think that helps people to be interested in what they're learning. And also, physics is not necessarily the most exciting thing, especially to high school students, but I think it's important that they know when they're going to need to use this kind of stuff. So what kind of jobs they can get with this information, with this degree, and so forth. And the second thing, and I think the most important thing to teach, is how to translate a problem into something that's solvable. So a nice, good problem-solving technique. And the third thing is the maths. So maths is the tool that we use for physics. So if you teach physics without maths, it's essentially like teaching a builder how to build a house by telling him what's in the house, what the rooms do, and giving him no further training. So if you do that, he'd be able to describe you a house beautifully, but when it actually came to building it, he'd be a dreadful builder. And in physics, it's the same with maths. If you teach physics without maths, they understand the concepts and they can get excited about the concepts, but then we're not actually teaching physicists and engineers how to do their job. So I have tried to include all three of these things in the way I've structured the course. And I have one last tip, which is if you have time to only focus really on one topic, choose vectors, because vectors are the fundamental thing that will get you through motion mechanics.
Yeah, but to keep you on track, there's assessment throughout the course. So you're going to have a number of online quizzes distributed throughout the course. There's also going to be experiments that you conduct, because physics is an experimental science, so it's important to know what measurements can be taken, how to take them. And then this course is going to also have a final exam. But you can find the details about all this stuff in the course outline. Okay, so we hope that you enjoy this course.